Okay, class, welcome back. Today we have another video, and the video is going to be about a lab that we're going to do together. Let's welcome our helper, James. Come on, James. How are you doing, James?
Good.
You're looking kind of spiffy today. I like that afro. Going back to the 70s like his mama used to do. Okay, looking good, looking good. Okay, so what we're going to do today, class, we're doing a lab demonstration. If you were in school with me, of course, we would do this lab together, but we have our helper, James, is going to help us today. So the first thing is we've been talking about disease for a while, okay? And so now we're talking about, just for today and maybe a couple of days later or more, we're going to talk about the immune system and how the immune system helps us fight disease. So the first thing you want to know is what is our first line of defense for our immune system, for our bodies? What's the first line of defense when we try and fight against disease? Anybody? Come on, somebody help me. What's the first line of defense? Say it.
Skin.
The skin. That's right. The skin's the first line of defense. So our skin is going to help ward off any kind of thing that's trying to get into our body. But let's say it gets into our body. Maybe we have a cut in our arm. What's going to be the second line of defense? For the first line of defense is going to be our skin and mucus. I messed it up. Skin and mucus. That's right, James. And second line of defense, if let's say that something does get into our bodies, what's going to help prevent us from getting sick? We had in our lab with a microscope, with the virtual microscope, we talked about these kind of cells. Kind of cells are called what? Come on, somebody help me.
White blood cells.
White blood cells. You know that, James? You know about white blood cells? Yes. So the white blood cells are going to help fight against bacteria or any foreign things that get into our body, okay? Now, that is second line of defense. What is our third line of defense? The third line of defense, believe it or not, is going to be our immune system. When our immune system causes our body to create antibodies. And we're talking about the word antibody at the end of the lesson. So antibody, when the word the word anti means against, body against a foreign substance that's in our body, okay? When I say foreign, I mean something that is not natural for our body. Our body recognizes it as being something that does not belong in our bodies, okay? Okay, good. So here we go. So who can tell me, do you know what your blood type is, James? No, you don't know. I know my blood type. I think my blood type is B, I think. I'm not sure. And you're right. I don't know your blood type. That's bad. Okay, I'm going to check that out, your blood type. Yeah, so what about you guys out there who are watching this video? Do you know your blood type? Do you know your family's blood type? Well, I have some questions here for you. Have you ever had a blood transfusion? You know, the word trans means across, so going from somebody else to you. And what kills bacteria in the blood? These are some questions that hopefully you know. If not know, we're going to know by the end of the day. Now, what's the function of blood? There are many functions of blood, and I did not put them all here because I have space. But the function of blood is to transport carbon dioxide waste from the body. So when we breathe in, our body's going to take in that oxygen, use it, and it's going to get rid of the waste, which is carbon dioxide. And the blood helps us do that. The blood also helps to defend against foreign substances in our body. It helps with clotting. If you get a cut, you're not just going to bleed forever because the blood is going to clot in order to prevent that blood loss. Well, hopefully, depending on what kind of cut it is. If it's real bad, then obviously it won't happen. Anyway, transport of oxygen from lungs to the body is also what helps with the blood. So these are some functions of the blood, and there are more, but I just want to give you the basic ones. So transport of oxygen, you know that, from the lungs to the body so that our body can use it, okay? Now, so what we're going to do, we're going to do a lab, and I'm going to read, let me see. Oh, I want to show you this photo right here first. I have my little notes here because I always forget something. I have it in my head, but I forget something. Anyway, so can you zoom in these two photos here, DJ? Okay, now, look at the photo. Blood has both a liquid and a cellular component. Look at the red blood cells. See the red blood cells here? These are red blood cells. I can't use my finger. These are red blood cells. And these right here are the white blood cells. See the difference in that? Okay, and then here we have some white blood cells and a red blood cells. See, you see the difference between this? This white blood cell is real big as compared to the red blood cell. The white blood cell also has a nucleus. Red blood cells do not have a nucleus, okay? Important to know that. All right, so today what we're going to do, you're going to help us do the lab today. And the first thing I'm going to do, I'm going to read the scenario on page C77. I'm not going to read C76 for lack of time. Anyway, I'm going to read it. Here we go. It says, immune responses of the human body are not always helpful. Any new material in the body, including blood and organs, can trigger an immune response. It is reaction of the immune system that makes organ transplants and blood transfusions difficult. If the blood type of the blood donor is not compatible with that of the person receiving the blood, the transfused blood cells are seen as foreign by the immune system and they clump together. These clumps can create blockages in blood vessels and cause death. That is why it's important to know which types of blood can be donated safely to people with each of the four human blood types: A, B, and O. So A, blood type A, blood type B, blood type A, B, and O. So remember, if you get the wrong blood, your blood can clump. Your blood sees it as being foreign, and your body is going to try to fight off that blood, and in essence, it's going to start causing you to have problems, and you can actually die, okay? So today, you will simulate what happens to a person's blood when blood from a donor is added, all right? So here is the scenario. It says, within each group of 4 students, and we're going to obviously do just James nowadays, okay? We get to do the work, okay? All right. Okay, part A and the other, okay. Anyway, so there are 3 patients needing blood transfusions. Can you look at this, James, DJ? There are 3 patients, Sasha, Fong, and Jordan. They all went to the hospital, and they all need a blood transfusion, okay? So they have arrived at the local hospital. This is a chart showing their blood types. In order to supply the blood, the hospital staff has asked the community to help. Some people respond by donating blood. The hospital receives blood donations of types A, B, and O. But these blood types might not be compatible with each patient. Now, here's the question. So we got 3 patients. Sasha has blood type A, Fong has blood type B, Jordan has blood type A and B. Okay, so the problem is we're trying to see whether or not the hospital has enough blood to give to the people. So the hospital receives blood donations of types A, B, and O, but these blood types might not be compatible with each patient. Does the hospital have enough of the right type of blood for each patient? Find out by testing samples of each blood type. Now, let me make this very clear. Having an A blood type or a B or O or AB does not have anything to do with anything, okay? Let me clarify that. That means that it's not, one blood type is not better than any other blood type. It doesn't mean that, oh, I have O, so I must be better than you. No, it doesn't. It's kind of like having brown eyes versus blue eyes. It doesn't do anything. There's no difference, okay? It's kind of like having brown skin versus white skin. Doesn't do anything, no difference, okay? So having a different blood type does not mean one blood type is more superior over the other blood type, okay? All right, so it is just a genetic difference, like having green eyes instead of blue eyes, or curly hair instead of straight hair. Okay, that's all it is. Okay, so let's get to our assignment now. So I'm gonna have our helper read, and then we're gonna. Oh, should I read it and then you do it, James? You want to read and do? You want to do both? Read and do it? Or should I read it for you? How about I read it for you? Okay, so we're gonna do. So we're going. Oh, I almost messed up. You have to hypothesize, class. See the hypothesis? So I'm going to give you a minute. I'm not really giving you a minute. I'm going to pause it when we're in class. And you're going to write your hypothesis. So your hypothesis, 2 things today. Your hypothesis will be the data table. And your hypothesis will also be written in an if-then statement. So for this part right here, I want you to pick one person. And I want you to hypothesize. So if Sasha received blood from A, is she going to clump or not clump? If Sasha received blood from donor B, is it going to be clumping or no clumping? If Sasha received blood from donor O, is it going to be clumping or no clumping? And same thing. So I want you to fill out each box here today, class, before we actually do the experiment. So right now, take a minute, and we're going to pause the video, and then you're going to fill out. We're going to put down either clump or no clump in each box. Clump or no clump. Clump or no clump. Don't pause it for real. Clump or no clump. And then you're going to say, if Sasha, or just pick any one of these people, if Sasha receives then what is going to happen? I want if-then statement. Okay, good. So class, hopefully by now you finished that. Now we're gonna get to our assignment. All right, so James, it says collect the 3 blood samples and the 3 serum samples. Do you have them, James? It says note, serum is blood that has had the red blood cells removed. In blood transfusion, the donor's blood must be compatible with the patient's serum. Design data table, we have data table for you already, right? To record your experiment results. So now, class, we're gonna put our results. This data table was our hypothesis, and this one's gonna be our results. So we have 2 data tables. This was our hypothesis or our prediction. Okay, and this one right here was our, it's gonna be our actual data, okay? So you ready, James? Okay, so James is gonna put, it says place 2 drops of Sasha's blood serum in cups 1 to 3. So here's Lil's cup. So can you do that quickly, James? You're gonna put, who's that? No. That's not right. You're gonna read it. Place 2 drops of Sasha's blood serum. Yeah, find Sasha. All right, you can put 2 drops in cups 1, 2, and 3. These are the small little cavity. Yep, 2 in each one. Good. Now you're gonna put 2 drops, and we're gonna put Sasha right here so we know that that was hers. Okay? And then we're gonna put 2 drops of Fong's blood. Let's put Fong in next. Let's put Fong next. You wanna show them that? That's perfect. Can you find Fong, James? So James is gonna put 2 drops of Fong's in 4, 5, and 6. In cavity 4, 5, and 6. Okay, let's show him that again. Okay, sorry about that. Okay, now he's gonna put 2 drops of Jordan's in 7, 8, and 9. Okay, James, now you can put 2 drops. Can you get A, blood type A, James? And he's gonna put 2 drops in cavity 1. And we're gonna see what happens. Now, in order to see what happens, class, we have to kind of shake it, because it's really hard to see if we don't shake it. No, not. Okay, now, can you see which of these clump? Can you guys see that? Which of those clump? Can I show these out the way, DJ, so you can see it? Which of those clump you think? We're looking at the red one now. So which one clumped? Which one clumped, James?
I can't really tell.
Middle.
That's right, the middle one clump. So remember, Fong is B, and he got blood type A, and his clumped. This one did not clump, and that one did not clump. So let me show you the names again, DJ. Okay. So the only for the first one, DJ, on your data table, we're gonna put down. Can you write it down for it? Can you hold it while you? I'll write it. I'll hold it while you write it down.
Clump and not clump?
Yep. So Sasha did not put down no clump. Oh, wait a minute. It's not. There we go. No clump. And then, so far, for the first part of the data table, let me just cover that. Sasha, she had no clump when she got it from donor A. Fong had clump me, got it from donor A. And then Jordan AB did not clump me, got it from donor A. Okay, good. Now let's do the next one, James. Can you find donor B? Donated blood B? Okay, good. And that was donor B. Donor B. And we're going to shake it up a little bit and see what happens. James, which one clumped?
Sasha's blood.
Sasha's blood clump. Very good. And what about the Fong's blood clump? Nope. How about Jordan's blood, James? Did it clump?
No.
No. And then that's no clump again, right? Okay, good. Now we have one more donator. All right, James. So now he has donor O. Go ahead, James. And we're going to shake that up. Ooh, they spilled. That's, you know, that's one thing about science. It's a little messy sometimes, class. Okay, let's look. Is it clumping anywhere? Which one clump?
This one.
Nope, that's not a clump. Did it clump? No clump. So let's go back to the clumps. Which one clumped again, GJ? Which one clumped again? This one for Sasha, right? Sasha, when she got it from B, clumped. Fong, when he got it from A, clumped. And Jordan, he didn't have any clumps, did he? No clumps. Okay.
So no one clumped
Right.
that time.
Nobody clumped. That's right. And they got it from donor O. So you probably say, why is that, right? Okay, well let's talk about that. Okay. Okay, when we saw that when Sasha got her blood from donor B, it clumped, right? Sasha was A, and she got blood from donor B, and her blood clumped. Now, why is that? Why is it when Fong got blood from donor A, now his blood type is B, why did his blood clump when he got blood from donor A? Okay, I'm gonna tell you why. Because your blood has markers. Because your blood is made up of red blood cells, white blood cells, platelets, and plasma. And your blood has markers. Markers are antigens, okay? Now, your body, if you have blood type A, you have a marker A in your blood. Okay, you have a marker. It's a microscopic marker in your blood, and it's marker A. If you have type B, you have marker B. If you have type AB, you have both marker A and marker B. But guess what? If you are blood type O, you have 0 markers. You don't have any markers. So what does it all mean? Okay, if I am blood type A and I'm trying to get, and somebody gives me blood type B blood, my body recognizes that as being foreign. You see? My body is going to recognize that marker B as being foreign to my blood type A, and therefore it's going to attack it. So, we also have positive or negative. Let me make this very clear. I probably said it too fast. Our blood has markers. Let me write this down. Where's my mark? Where's my thing here? Okay, sorry.
Where's your marker?
If I have blood type A, if I'm blood type A, and somebody tries to give me blood type B, my blood does not have the marker B. See, because I'm blood type A. So it's going to see this blood B as being foreign to my body. And what is my body going to do? It's going to attack it. It's going to try and fight it off. And in attacking it, it's going to hurt myself, and I'm going to have all kind of problems. I can have kidney failure. I can die, okay? So this is very important to say this. So the marker that I have determines what I can receive. If the blood does not have the same marker I have, I cannot receive it. That makes sense? If blood does not have the same marker that I have in my body, then I cannot receive that blood. Okay? However, if it has 0 markers, I can receive it. Look here, guys. Sasha, Fong, and Jordan were all able to receive blood type 0 because 0, I said 0 is O, but I say 0 because it doesn't have, it has 0 markers. They were all able to receive blood type O because it doesn't have any markers. So their body did not recognize it as being foreign. So let's go back here. We're almost done now. So the RH factor, or the marker, it determines if you're a positive or negative. So you probably heard of O positive, O negative, A positive, A negative. The positive simply means if you have the RH factor, you have that marker. If you have negative, that means you do not have that marker. You do not have the RH factor marker. So what happens then? Well, our body is going to produce an antibodies against foreign bodies. It's going to produce antibodies to fight against foreign cells that enter our body. So who's the universal donor? If you have O negative, that means you don't have any markers at all. That means anybody can take your blood, which is great. They want people who are O negative to go and donate blood. But if you are AB positive, that means you can receive from anybody because you have the A marker, you have the B marker, and you have the RH factor marker. You have all 3 markers in your blood. You can take from anybody, but an O negative person can give to anybody. Does that make sense? Okay, good. Question, you have a question right here, huh?
What kind of blood can the O negative receive?
That's a good question. What can they receive? Only O negative. They cannot receive O positive because O positive has the HR factor. They can only receive O negative. That's a bummer. They can't receive A because A has a mark. Their body is going to fight against that. That makes sense? They can only receive O negative blood. Okay, that was a good question, everybody. I'm sure you have more questions too. You can go to your local library and research it. Just kidding. Okay, we'll talk about it in class. Let's say thank you to our helpers today. Our James, say hey. We'll say thank you to James and to my son DJ, who's a photographer. And of course, I'm your teacher, Mrs. Penix. We'll see you in a little bit. Bye-bye.